Welcome back everyone. Session for Advanced UI Interactions. Everything we have done so far has been fairly well behaved. Buttons, forms, text fields. Today we get into the stuff that actually trips people up in real applications. File uploads and downloads, iFrames, pop-ups and new tabs, native browser dialogs, drag and drop, and content that loads dynamically as you scroll. These are the scenarios that don't show up in a simple demo, but absolutely show up the moment you're testing a real production application. Quick recap of session 3. Web first and soft assertions, test.describe and hooks, annotations, test.step, tagging, and test data strategy. Today's agenda, 6 things: file upload and download handling, iFrames using frameLocator, new tabs, windows and pop-ups, native dialogs, alert, confirm, and prompt, drag and drop, plus low-level keyboard and mouse control, and dynamic content, including infinite scroll. Let's start with file upload, and I want to open with some good news. This is actually much simpler than a lot of people expect. Playwright doesn't need to drive your operating system's native file picker dialog at all. It just sets the files directly on the input element itself. Here's the code: await page.get by label upload resume.set input files resume.pdf. Two things worth knowing. First, no OS dialog is needed. This works completely headlessly with zero native file picker automation required, which historically was a genuine pain point in older automation tools. Second, it accepts multiple formats: a single file path, an array of paths for multiple files, or even in-memory buffers with a name and a MIME type, which we'll look at next. Let's look at the full range of ways you can call this: single file, by path, setInputFiles, files/resume.pdf, multiple files, pass an array of paths instead. And here's a neat one: an in-memory buffer, with no file needing to exist on disk at all. You pass an object with a name, a MIME type, and a buffer built directly from a string. So you could generate a fake CSV file on the fly entirely inside your test code. And to clear a selection entirely, just pass an empty array. That in-memory buffer trick is genuinely useful. No fixture files cluttering up your repository, no cleanup needed afterward. Now let's flip it around. Files coming out of the application rather than going in. Downloads are captured as an event, so you have to listen for that event around whatever action triggers the download. Here's the pattern: const download in brackets equals await promise.all, and inside that array, page.waitForEvent download and page.getByRole link download csv.click. The critical detail here: promise.all starts listening for that event before the click happens. If you were to click first and only start listening afterward, you could genuinely miss a download that fires immediately, and this is a mistake I see constantly. So really internalize this pattern now. Once you've captured that download object, here's what you can actually do with it. Same setup as before: promise.all, waiting for the download event alongside the click. Then expect download.suggested file name to be export.csv, so you can verify the browser is actually offering the correct file name, and then await download.saveas, pointing it at a path like /tmp/downloads/export.csv. Once you've saved it, you can go a step further and read that file's actual contents using Node's fs module to assert on what's really inside it, not just that a download happened at all. Let's talk about iFrames, because this one confuses people the first time they hit it. An iframe embeds a completely separate document with its own entirely separate DOM, and page.locator by default only searches the top level document your test navigated to. So, if you try to find something inside an iframe using a regular locator, it simply won't find it. Not because your locator is wrong, but because you're searching the wrong document entirely. Picture it as a page within a page. The top level page contains an iframe, and that iframe is its own separate document with its own set of elements that needs to be explicitly entered before you can locate anything inside it. Here's how you actually get into that iframe. Const a payment frame equals page.frameLocator with a CSS selector targeting the iframe by its name attribute. Then from that point on, payment frame dot get by label quote card number quote comma dot fill and payment frame dot get by roll button comma quote pay quote comma dot click. Three things worth knowing. frameLocator returns a scoped locator root, and you chain any normal locator off of it exactly like you would off of page. It auto waits for the iframe itself to be attached, just like element locators do. And for nested iframes, an iframe inside another iframe, you simply chain dot frameLocator again on the result, as many levels deep as you need. Let's move to new tabs and pop-ups. A click that opens a new tab using target equals underscore blank or a window.open call actually creates an entirely new page object, and you need to explicitly capture it. Here's the pattern. Const new page in brackets equals await promise.all with context.wait for event page alongside the click that opens it, and then await new page.wait for load state. Worth knowing that new tab is a fully independent page object with its own locators and its own lifecycle, but it still shares the same underlying browser context as the page that opened it. There's actually a more specific shortcut for the common case of a page opening a pop-up. Same promise.all pattern, but this time we wait for page.waitForEvent pop-up instead of context.waitForEvent page. What's the actual difference? Context.waitForEvent page fires for any new page anywhere in that context. Page.waitForEvent popup fires specifically for a page that was opened by this particular page. So popup is the more targeted, more common choice when you already know which page is doing the opening. Let's talk about native browser dialogs: alert, confirm, and prompt. These block the page entirely while they're open, and by default, Playwright will just auto-dismiss them unless you explicitly register a handler yourself. Alerts just informs the user, and accept is the only option available. Confirm, accept clicks OK, dismiss clicks cancel, and prompt accept with a text value, fills in that value, and then clicks OK. Let's talk about native browser dialogs: alert, confirm, and prompt. These block the page entirely while they're open, and by default, Playwright will just auto-dismiss them unless you explicitly register a handler yourself. Alerts just informs the user, and accept is the only option available. Confirm, accept clicks OK, dismiss clicks cancel, and prompt accept with a text value, fills in that value, and then clicks OK. Let's move on to drag and drop. There's a high-level API for this, and it's refreshingly simple. Await source.drag to target. That one call handles hovering, mouse down, moving, and mouse up, all for you automatically. But there's also manual control available when you need it. For custom drag behavior, you can compose page.mouse.move down and up directly yourself. One caution worth flagging: some custom drag and drop libraries, particularly certain HTML5 drag and drop implementations in specific frameworks, need manual mouse events specifically, because .drag2 doesn't always fire the exact synthetic events those libraries are listening for. Let's see both approaches side by side in actual code. High level, one call page.getByText task card.drag to page.getByText ad don't column. Manual step by step. Grab locators for the source and the target, then call source.hover, page.mouse.down, target.hover, and finally page.mouse.up. Start with the high level dot drag to every single time. Only drop down to the manual version if you actually hit a real problem with the simple approach not working correctly. Sometimes you need to go below the locator API entirely, straight to raw keyboard and mouse control. Page.keyboard.press tab simulates a raw key press that isn't tied to any specific element. Page.keyboard.type with a string types character by character, though this is rarely actually needed over just using dot fill. Page.mouse.move x, y moves the mouse to absolute coordinates on the page, and page.mouse.wheel simulates scrolling. Important caveat here. Prefer locator-based actions like click and fill whenever you possibly can, because those auto-wait for you automatically. Only reach for these lower level APIs when there's genuinely no element based option that fits what you're trying to do. Let's talk about content that loads dynamically as you interact with the page. Here's a knife looking approach. Grab a locator for list items, then loop scrolling the mouse wheel and waiting briefly until the item count reaches 40. But here's the better guidance. Prefer waiting on a real signal instead. A new network response landing, a count actually changing, or some kind of loaded marker appearing on the page. To have count is itself a web-first assertion, and it can very often replace a manual polling loop entirely, cleanly. And for lazy loaded images or content specifically, you may need to call scroll into view if needed before you can actually interact with something. Let's cover the anti-patterns for everything in today's session. Waiting for events after the click. Wait for event has to be registered before the triggering action, wrapped inside promise.all, not called afterward. Forgetting the dialog handler. Without page.on dialog, Playwright silently auto-dismisses it, which quietly changes your application's actual behavior compared to what a real user would experience. Manual mouse events by default. Reaching straight for page.mouse first when .drag to or a regular .click would have worked fine and given you auto waiting for free. And polling loops instead of assertions, hand rolled while loops using wait for timeout are both slower and flakier than just using to have count. Let's put everything from today together in one realistic complete example. A test called import then export a report. First, we upload a file using setInputFiles. Then we register a dialog handler that just accepts whatever comes up. Then we click process. Then using our promise.all pattern from earlier, we wait for a download while clicking export. And finally, we assert that the download's suggested file name is exactly report.xlsx. Notice, this one test touches upload, dialog handling, and download, and every single piece follows the exact patterns we covered today. Nothing new, just composition of what you already know. Your turn. 5 things. 1. Automate a file upload using setInputFiles and assert that the file name actually appears somewhere on the page afterward. 2. Trigger a download and assert on its suggested file name. 3. Find a page containing an iFrame and interact with an element inside it using frameLocator. 4. Handle a confirm dialog. Accept it the first time through, then dismiss it on a second run instead. 5. Implement a drag and drop reorder using .drag to, and then again using the manual mouse approach, so you've genuinely done both. Let's recap. 4 things to hold on to. setInputFiles sets files directly, no OS dialog automation required at all. Always register your wait for event or dialog handlers before the action that actually triggers them. frameLocator scopes your locators into an iFrames separate document, and prefer .drag to and web-first assertions over manual mouse loops, wherever that's genuinely possible. Next time, session 5, page object model and fixtures. We'll cover why and how to structure a scalable framework using page object classes, Playwright's custom fixtures through test.extend, and shared login state through storage state. That's where this whole project stops being a folder of scripts and starts becoming a genuine maintainable framework. Any questions, please post in comments section.